Welcome dear friends, learners and all my dear students. Myself Dr. Vipin Maurya, Department of Livestock Production Management, Faculty of Veterinary and Animal Science and Banaras Hindu University. Welcome to the course of Animal Waste Management. This is the 6th lecture of the first week. So welcome back. And we are going to discuss the fundamentals of the animal waste management, where we will be discussing about the piggery, the fishery waste, the abattoir waste and the animal related industry waste. Piggery and fishery waste, we will be discussing all the introduction, and we will be discussing how this abattoir waste, the piggery waste and animal related waste, they can be generated towards the products of the animal utility, and how we can create the renewable sources of energy. How we will be generating the wealth from these wastes. So starting with the piggery waste. So piggery waste management is an essential part of the livestock farming, as it generates a significant quantities of the waste. So pigs are reared all over the world for food security, for economic benefits, because it provides a profitable agricultural enterprise, for the resource utilization, for the research and development, as the pig models are used for various biomedical research, contributing to the advancement of the human health and disease prevention. And pigs are also cultural religious significance. They are having a cultural and religious significance which play an important role in the traditional ceremonies. Pigs, they are having a very less gestation period, only 112 to 114 days, and the litter size is very large. That is 8 to 12 litter size we get from one farrowing, and the farrowing interval is again very less, only 210 to 240 days. The growth rate is very rapid in case of pigs, and the feed conversion ratio is very high. And the carcass is also high with less dressing percentage, and the adaptability of the pigs is very good. Therefore, the pigs are considered to be a very good food animal as well as the meat animal, and it is being reared all over the world as well as in India. India, which is having a population of 9.06 millions, with according to the 20th livestock census, and the smallholder farmers, they are having a larger proportion of the pig farming in India, which is practiced by the smaller farmers. The pigs, they are reared in Bihar, Uttar Pradesh, Assam and northeast regions, where the piggery waste management presents both challenges as well as opportunities. And despite these challenges, these have a very good utilization potential. It offers the opportunities for the energy production and organic fertilizers, particularly in the rural areas, where the resource recovery from the waste can significantly enhance the agricultural productivity, energy and self-sufficiency. So the major concerns of the piggery waste management is the volume of the waste. So 770 million tons pigs, the population of the pigs, they are generating a huge amount of waste, which if not properly managed can lead to the environmental impacts, like we have already discussed in the last few lectures, that how ammonia and methane causes environmental pollution, air pollution, how the wastewater can cause the problems in the water pollution, and how the soil degradation takes place. And the pigs, they are monogastric animals. So they produce a huge amount of nutrients in their feces, which can again pose threat to the animals, as well as humans, causing zoonotic diseases. The piggery waste is a valuable source for producing the biogas, the organic fertilizers and soil conditioners. This waste, or rich in nutrient nitrogen, the phosphorus potassium, and organic matter, which has immense potential for the use in the agriculture and energy production. So, how will we classifying the piggery waste? So, solid waste, the liquid waste, and the gaseous waste. Solid piggery waste includes the manure, the feces, and the urine solids, which is composed. Then, bedding materials. So, straws, the wood shavings, and other materials which is used as the bedding can be mixed with the manure and creating a high fiber waste. Then feed wastage, the spilled or the leftover feeds of the piggery, they are the feed wastage, and sludge from the storage lagoons. So, this is a system where you can see how we are going to classify the piggery waste. So, classification, the solid waste, the pig manures, straws, sludge and lagoons, the liquid waste, the urine, the slurry, the effluents comes under the liquid waste, and all the gases which we have already studied, they comes under the gaseous waste. The pathogens and the pharmaceuticals, or we can say the residues of the antibiotics, it comes under the hazardous waste. And the examples of this are salmonella, the antibiotics, the hormones. Then coming to the composition of the waste produced by the different species. So, we have already understood the composition of the cow and the poultry. Today, we will be discussing about the composition of the pig manure, the horse manure, and the fishery waste. So, the pig manure, it contains 15% of the organic matter, whereas the horse manure has 20% and fishery waste, they have 25% of the organic matter. Similarly, the nitrogen content in the pig and the horse manure is around 0.5 to 0.6, whereas the nitrogen content is very high, that is 2.4 in case of the fishery waste. The phosphorus content is again 0.4 in case of the pig waste, whereas in fishery waste we have 3.2% of the phosphorus. The potassium concentration or the calcium, the potassium it is almost 0.4 to 0.6, and the calcium percentage in fishery waste is highest, that is 5.5%. Then the carbon nitrogen ratio or the carbon, so carbon it is 20-25% in everyone, whereas the horse manure it is having 30 to 35% of the carbon. The carbon nitrogen ratio it is 17 to 18, which is very good for making the biogas, as it is comparable with the cow dung. Similarly, the carbon nitrogen ratio in case of horse it is 20 to 25. So, this is an example of the piggery farm waste management system, where we can see the various methods of generating revenue from the waste. So, how we will be managing the solid waste? We have already discussed in the previous lectures that the solid waste can be easily composted, and composting is a aerobic biological decomposition of the organic matter such as the manure, the bedding and the feed waste, which produces the organic fertilizers and reducing the need of the chemical fertilizers. Similarly, the compost of the pig, it is rich in nitrogen, phosphorus and potassium, which is ideal for the soil amendments. Then coming to the vermicomposting, that is the use of the earthworms for composting or converting the manure into a higher nutrient content and traditional compost. So, manure drying and storage can be done. So, a drying of the manure to reduce the moisture content. So, it will be very easy to handle or transport such type of manure. Then coming to the liquid waste management, which is a very challenging thing in case of the piggery. So, effective management involves the reducing the potential for the water pollution to make the use of the liquid, nutrient rich liquid. So, we can go for the anaerobic digestion, where the microorganisms break down the organic matter in the absence of the oxygen, producing the biogas or the methane and the digest state. Now, the challenges are That it requires an investment in the infrastructure, it requires regular maintenance and skilled labor to operate the things efficiently. In the upcoming lectures, we will be discussing how we can go for liquid waste management, how we can go for a wastewater treatment in an effective and detailed manner. How we'll be going for the gaseous waste management like the biogas production, the ammonia emission control, the methane capture and utilization. In a very detailed manner, we'll be understanding all these things regarding this. Then coming to the pathogen control. Piggery waste contains various pathogens which are again zoonotic in nature. And what we can do the heat treatment to kill such pathogens before applying it to the land and reduce the spread of the diseases. These pathogens include the E. coli, the salmonella, the tuberculosis, and composting and vermicomposting, again, they can reduce the harmful pathogens. So this is an example of anaerobic digestion where we can convert the pig waste into various items of utility like biogas, the digestate, the fertilizers, then coming to disposal methods. So the traditionally following disposal method everywhere in the rural India, it is the land application or the land fillings. So, and it acts as a very good nitrogenous fertilizer for the soil, as it recycles the nitrogen, phosphorus and potassium back into the soil, promoting the crop growth and enhances the soil structure and water retention through the organic matter content. And it is a very cost effective disposal method, but the problem is if we do over application, it leads to the nutrient runoff, leaching or underground water contamination may occur, as well as odor and pathogen issues are there if it is not managed properly. So seasonal constraints, the manure application must align with the crop nutrient needs. Best practices for the land application is to ensure the appropriate application rates based on the soil test and the crop needs. So buffer zone to prevent the manure runoffs into the water bodies, and this manure, it can be used in the soil to reduce the nutrient runoffs. There are nutrient recovery technologies also, like the struvite precipitation and ammonia strippings. So they are the advanced nutrient technologies for focus on the extracting the valuable nutrients like the nitrogen, phosphorus, potassium, like the struvite precipitation, where the phosphorus and ammonia are precipitated from the piggery wastewater in the form of the struvite, which is the magnesium ammonium phosphate, which is a slow release fertilizer. So struvite, which is used as an effective phosphorus fertilizer, it recycles the phosphorus, reduces the risk of eutrophication and provides an alternative source of the phosphorus for the agriculture. Then ammonia strippings. Ammonia is stripped from the liquid pig manure or wastewater through the heat or airflow and captured as the ammonium sulfate or ammonium nitrate. So ammonium salts are applied as fertilizers in the crop production. So how we can generate the waste from wealth from the piggery waste? So generation of the wealth from the piggery waste, we can do the convert this waste into the biogas, the organic fertilizers, the animal feed, bio oil, biochar, compost tea. Compost tea is a liquid solution rich in the beneficial microbes for the plant growth production. So this we have already discussed in the first lecture. Then the fish feed, the methane gas, which can be again used for the injection into the natural gas pipelines or used as a renewable source of energy. Then carbon-rich soil amendments for enhancing the soil fertility and mitigating the climate change. And value-added products like the bioplastics, cosmetics, pharmaceuticals through advanced processing technologies. So the bioplastics, they are the biodegradable plastics for packaging, agriculture and medicinal applications. The cosmetics, they are ingredients like the glycerin, fatty acids and peptides for skincare and personal care products. The pharmaceuticals compounds like chondroitin, glucosamine, and hyaluronic acid for joint health, wound healing, and other applications, and food ingredients, protein-rich extract, flavor enhancers, or texture, or for the human consumption. Then we can use it as a special feed additives in animal nutrition, like the immunoglobulins. Then surfactants and enzymes for industrial household, like the detergents and the cleaning agents. And the biotechnology applications can be done like enzymes, bioactive compounds, and other biomolecules for the research, diagnostic, and therapeutic purposes. So these value-added products not only increase the economic value of the piggery waste, but also reduce the waste disposal costs and environmental impacts, provide new revenue streams for the farmer processors, offer innovative solutions for various industries. Now coming to the fishery waste management. Again, the fishery waste, it is very important to manage because the global fish production includes both capture fisheries and aquaculture, which has reached the record levels with more than 178 million tons of the fish produced in 2020. And approximately 35% of this production is either lost or wasted annually, primarily in the form of the processing waste or discarded fish. So fishery waste can be categorized into the solid waste, the wastewater, and the gas released during the processing. So global fish waste generation, it is estimated to around 20 to 50% of the total fish weight, which has turned into the waste during the processing, which includes the bones, the hides, the viscera, and the skins and the scales. So fish waste production varies widely across the region, with the Asia accounting for a significant portion due to its large fishery and aquaculture industries. Southeast Asia and China in particular are among the leading producers of both fish and the fishery waste. In India, 14.16 million tons of the fish in 2021, this is a record of the government, and India ranks second largest fish producer in the world. So fish waste production in India, with approximately 30 to 40% of the total fish biomass considered as the waste, it is estimated that India generates around 4 to 5 million tons of the fishery waste annually. So major waste sources, of the fish waste, they are marine fishing industries, freshwater fisheries, aquaculture farms, and fish processing plants. The primary waste components are fish scales, the skins, the viscera, the bones, and the shellfish or the exoskeleton. So the fish head and the bones, they are high in collagen, calcium, and protein. Fish skin and scales, they are rich in collagen, omega-3 fatty acids, and fish viscera, it contains enzymes, proteins, and fats. So the disposal methods of the fishery waste. As the perishable nature of the organic matter and the high risk of the environmental pollution, several disposal methods are employed across the globe with varying degree of the environmental impact. So landfilling, which is the traditional practice, however, it leads to environmental hazards such as groundwater contamination, odor issues, and methane emissions. Second method is incineration. So incineration of the fishery waste can be done to reduce the volume of the waste. However, the high moisture content of the fishery waste makes the thermal disposal energy intensive, and it emits harmful gases also and the particulate matter, which may lead to the environmental pollution. Ocean dumping. It is illegal as well as harmful. So, and it now has been prohibited due to the detrimental effects on the marine system. Pollution and toxicity. Dumping the fish waste into the water bodies leads to the eutrophication, depletion of the oxygen, and disruption of the aquatic life due to the organic pollution. So what we can do? we can go for integrated fish waste treatment system. We can go for the effluent treatment plants. So what is integrated waste system? So modern fish processing plants utilize integrated waste management system that combines several treatment technologies, including the mechanical separation, biological separation or biological treatment, and chemical treatment. Biological treatment like the composting and anaerobic digestion, and the chemical treatment like the rendering of this, which enables the efficient waste segregation, and the valuable components like the proteins and the fats can be segregated easily and processed. Similarly, the effluent treatment plants, which treat the wastewater generated from the fisheries, they remove the physical, chemical and biological contaminants, making the water more suitable for the discharge and the use, which helps to reduce the water pollution. So fish waste can be composted to produce nutrient-rich organic fertilizers. So this composting and biogas production, they can be used to reduce the microbial activity and produce the manure and the renewable sources of the energy. Now, coming to another very important topic, that is the utilization of the fish waste. Value-added products such as fish meal, fish oil and collagen are produced from the fish waste. So fish meal and fish oil, the production process is very simple by cooking, drying and grinding to produce the fish meal, which is used as a high protein feed for the livestock and the aquaculture. Fish oil is extracted from the fish waste and used in the pharmaceutical and nutritional supplements. So aquaculture and livestock feed, so which is a very rich source of the protein, particularly it is used in the aquaculture, and nutrient supplements like the fish oil, which is rich in the omega-3 fatty acids. So fish waste can be converted into the collagen and derivatives by the ultrafiltration and nanofiltration techniques, the peptides and the proteins, the chitin and the chitosan, the oils like the omega-3 fatty acids and enzymes. And this is the extraction and processing process of the fish waste. Collagen and gelatin, they are extracted from the fish skin and the scales, while the gelatin is produced by further processing the collagen. So gelatin is used as a gelling agent in various food products. It is also used in the ice creams and various pharmaceutical products. Collagen, it is used in the skincare products for its moisturizing and anti-aging properties. So fish waste in agriculture, we can generate the organic fertilizers from the viscera of the fish and fish hydrosylates. So organic fertilizers are rich in the this nitrogen and nutrients, and fish hydrosylates, they are the enzymatic breakdown of the fish waste which produces the fish hydrosylate, which is again used as an organic fertilizer to promote the fish health. Then enzymes and the bioactive peptides. Fish viscera, head and other waste are rich in bioactive compounds and enzymes that can be extracted for the use in the food, pharmaceutical and biotechnical industry. So enzymes like the proteases, lipases, chitinases are used in the food processing and bioremediation. Enzymes and bioactive peptides extraction turns low value waste into the high value byproducts. Then fish silage can be prepared, which is a liquid product made from the fermenting the fish waste with acid or the enzymes, where the proteins, they are converted to the liquid form, which can be used as the animal feed or the fertilizer, and then this is an economical and efficient way to utilize the small fish or byproducts that would otherwise be discarded, contributing to sustainable waste recycling. Then chitin, chitosan production. Chitin is a polymer found in the cells of the crustacean and can be extracted from the fish waste and processed into the chitosan. Chitosan is used in the wastewater treatment, agriculture, biomedicine due to its biocompatibility and biodegradability. So, fishery waste management, what we have learned, the fish silage can be made by the enzymatic breakdown to create the protein rich feed for the animals. Then fish meal and the fish oil production can be done. Then the composting of the fish can be done, and this fish waste can be done, which is an anaerobic decomposition, and anaerobic and finally the landfillings can be done by the disposal of the fish waste. So, common techniques of this fish waste management are recycling, reusing, so reusing the waste as a fertilizer or feed, then reducing, so minimizing the waste generation through the efficient practices, then the proper storage, storing the waste in the designated areas to prevent the pollution, and finally the regular monitoring, the tracking of the fish waste to ensure the effectiveness. So, this was all about the fishery management. We have covered the fisheries and the piggery. Now, we are going to touch another very important topic, the slaughterhouse, the abattoir, the meat processing industry. So, abattoir and the meat processing waste, we will be learning its status, its methods of disposal. So, abattoir, it generates a significant amount of the waste in the form of the blood, the bones, the fat, meat scraps, animal tissues, organs, manures and water effluents and packaging materials. So, global meat industry is significant contributor to both economy and environmental challenges due to the large amount of the waste it generates. Meat processing waste includes the byproducts, which we have already discussed, like the blood, bones, feathers, offals, hides, effluents, which if not managed properly can lead to environmental contamination. So, globally 340 million tons of the meat is produced annually. This is the data of 2023. For every kg of the meat produced, 50 to 60% of the animals may end up as waste or the byproducts. So, major meat producing countries like China, US, Brazil, India and Russia generate a large quantity of the meat waste annually. The meat processing industry generates 150 million tons of the byproduct, and the live weight can be categorized into the edible, inedible and discardable byproducts. So, discardable part amounts for 66% in the cattle, 52% of the live weight and 80% of the pig live weight. Now, India, it is one of the largest producers of the buffalo meat and a major player in the poultry industry, which generates an estimated 5 to 6 million tons of the meat processing waste annually. Poultry waste, such as feather, blood and offal, is one of the most significant type of the waste, especially with India's rapid growing poultry consumption. India produces 6.3 million tons of the meat, standing fifth in the rank in the world's meat production. So, again, the type of the meat processing waste, they are solid waste, solid, then liquid and gaseous. Like the feathers, bones, hooves, horns, hides, they come under the solid waste. Similarly, the effluents from the washing, cleaning and sanitizing the equipments come under the liquid waste. Gaseous emissions, ammonia, methane and hydrogen sulfide, they come under the liquid waste. So, this is an example depicting how the slaughtering of the animals generate the waste and how the slaughtering process is on. So, we have already discussed the abattoir byproducts, like the edible byproducts like the offals, the internal organs, gelatin, fat. Inedible byproducts like the blood, bones, and the discarded material. Similarly, the liquid waste, solid waste and gaseous emissions we have already covered. Now coming to very important topic, that is the recycling and utilization techniques. So first is the prevention. We should try to prevent, to reduce the waste generation through better practices. Then we should try to recycle and reuse this waste, and we also should try that the treatment can be done so that the waste can be managed very efficiently. And finally, if no resources there, then only we should go for a landfilling or incineration as the last resort. So disposal methods, again the same disposal methods like the other animal waste. So we can go for the landfillings, incineration and composting. So waste management systems in the meat processing. So waste segregation and collection. So effective segregation of the organic and non-organic waste at the processing site is critical. On-site rendering units can be done, effluent treatment plants which will reduce the COD or BOD, that is the biological oxygen demand and the chemical oxygen demand. Then liquid discharge, zero liquid discharge system which ensures that no liquid waste is released into the environment. And finally, the integrated waste management system where the combining the rendering, the biogas production and composting to ensure the minimal waste generation. Byproducts are processed into the animal feed, fertilizer or energy, while the effluents are treated for the reuse. So this is a solid waste treatment and disposal technique where we can go for rendering, composting, incineration, pyrolysis, biodiesel production, anaerobic digestion and finally the landfillings. So this is a liquid waste treatment, example of a liquid waste treatment where we can go for the anaerobic treatment, aerobic treatment and the filter press where the sludge dewatering for the waste reduction can be done. So recycling and reutilization can be done by rendering. Animal feed ingredients can be made from the meat meal or the bone meal, as well as the blood meal can also be used to make the high protein products. Similarly, tallow and lard, which are the fat recovered from the cattle and the pigs respectively, can be used for making the soap, the biofuel and the cosmetics. The gelatin and the collagen, so bones, tendons and skins are used to extract the gelatin and the collagen, which are used in the food, pharmaceutical industry and the cosmetic industry. So biofuel production, the biogas production, the biodiesel production, which the leftovers can be used for making the fertilizers and the soil conditioners. And pet food industry, the non-edible parts like the organs, the feathers and certain meats are processed into the pet food. Then the bioplastics and other biomaterials can be generated from the collagen and the keratin, and which can be used to develop the biodegradable plastics. And there is a lot of industrial application. The fat, the bones and other animal byproducts are promising source for producing the industrial lubricants, bioadhesives and even the textiles such as the leather-like materials. So this is an example and a flow chart showing the biodiesel production from the animal fat waste, where the slaughterhouse byproducts, they are rendered and then the biodiesel can be produced. So rendering, the fat and the meat byproducts are processed into the tallow and meat and bone meal. Similarly, the glue can be manufactured through rendering process. The cosmetic production can be done, and the food industry, which is used by the byproducts, uses this byproducts for making the gelatins and used in the desserts and food thickeners. So keratin, which is found in the hair, wool, nails, hooves, horns, bones and feathers, can be used for creating the sustainable materials and figures prominently in the textile and the biomedical applications. Innovative application of the keratin, edible packaging. So keratin, the products of the keratin, composites of the food preservation, then tissue engineering, drug delivery, and textile applications. So this is a complete picture showing how and what products can be generated from the various parts which are not edible, and how we can utilize the slaughterhouse waste or the meat processing waste. Then coming to the tannery waste management system. So the global leather production, it is around 20 billion square feet of the leather annually, which results in 4 to 5 million tons of the solid waste per year. Chromium based tanning dominates the industry, contributing to the 90% of the global leather production, which generates hazardous chromium waste. So tannery waste production, the water consumption, it is around 30 to 40 cubic meters of the water per ton of the hide produced, which results in a significant amount of the contaminated effluents. The key pollutants include the chromium, sulfides, acids, salts, fats, and oils, which are often discharged into the water bodies, posing environmental and public health risk. So again, the utilization of the solid waste or the leather trimmings in the shavings can be done. Gelatin and collagen production, the fertilizer production, the composite materials. So the leather board and other composite materials can be used in the making the shoes and the furniture industry. Similarly, the fleshings, the fatty waste can be used in the biofuel production, the animal feeds, and the composting. Hair and the wool waste can be used in the fertilizer production and the protein extraction. The utilization of the liquid waste. So chromium recovery can be done, and alternative tanning agents can be done, which are apart from the chromium. We can use the vegetable tannings or synthetic tannings. Similarly, treatment of the wastewater, the biological treatment can be done to reduce the biological and chemical oxidant demand of the water. Constructed wetlands can be made for effective treatment of the tannery wastewater. Then membrane filtration techniques can be used, and zero liquid discharge system, which we have already discussed, can be used for conversion of the, coming to the recycling byproducts. So leather dust in the plastic and the rubber, leather in the fashion accessories can be made, like the belts, wallets, and other leather goods can be created from this. There are biotechnological solutions also, like the enzymatic dehairing, microbial treatment of the effluents. Then coming to a last topic, that is the products of the animal utility from the animal waste. So the animal waste can be converted into the valuable products that serve multiple industries, such as the agriculture, the pharmaceutical, and the cosmetic. The byproducts of the meat, dairy, and the poultry industry, such as the bones, the blood, feathers, and fats, can be processed into the useful products, like the decorative items, the bone meals, the blood meals, the meat food meal. So we have already discussed about the bone meal, which is the finely grounded product made from the animal bones, and which can be used as a fertilizer as well as the animal supplement, as it is very rich in calcium and phosphorus. So it can be used as the very good supplement in the animal feed. And the bone meal, it is also used in the production of the bone china and other ceramics. Then blood meal. Blood meal is a high nitrogen organic fertilizer made from the dried animal blood, which is commonly used for fertilizers, animal feed, and biochemical productions. So blood meal can be used in the production of the enzymes or other biochemical products. So blood meal, it is a very good protein supplement. Neat's foot oil. It is a bioproduct of the leather industry made from the rendered fat from the lower legs of the cattle. And it is used widely to soften and preserve the leather products. It is used as a lubricant in certain industrial applications. Feather utilization can be done. So Feather byproducts, various decorative and industrial agricultural products can be made. Feather meal can be made, which is again a high protein animal feed supplement. Then decorative uses of the feather can be done, which is used in the fashion and craft industry for decoration and ornamentation. And feathers have been investigated for the production of the biodegradable plastics and insulation material. Finally, the wool processing. From the sheep, we get the wool, and the processing's waste includes the clippings, the offcuts, and the wastewater. So, recycling and reutilization of the wool processing waste can be done through the composting, making the fertilizers, making the bioenergy. The textile products like the wool waste can be recycled into the new textile products for reducing the need for the virgin wool. Then, the wool waste can be used in various industrial applications such as the insulation material, filter, and animal feed. What we have to do? We have to follow the good manufacturing and hygienic practices by regular inspection, compliance with the health regulations, proper sealing of the animal organs to prevent the contamination, properly managed drainage system for the liquid waste, and strict protocols for handling the diseased animals and the waste animals. So, to conclude, I would like to say we can generate a huge amount of wealth from these wastes. We can generate the products of the animal utility, products of the human utility, and we can reduce the pollution, the water pollution, the air pollution, the soil degradation, and we can reduce the nuisance, we can reduce the disease spread, which will ultimately lead to the increase in the soil health, environment, and it acts as an alternative source of the renewable energy, fuels, pharmaceuticals. We have discussed so much of the byproducts where we can create wealth from these wastes, and ultimately we can reduce the water contamination and increase our water quality. So, this was the last lecture of the first week. Dear friends and my students, keep learning, keep enjoying. If there is any doubt, any query, feel free to contact us. Thank you.